welcome to Singapore. Oh my gosh. Can you do that thing? Yeah. Full screen. That, yeah. Just go back one. There we go. Anyway, you probably have all seen the note well before, but I'll put it up here for just a second since it is Monday, right? Yeah. Yeah. Oh my gosh. Okay. Blue sheets are going around. No, they're not. Blue sheets will be going around momentarily. I believe we have Elliot taking notes and somebody doing jabber. I guess the next thing would be working group documents. So who do we have up first?
Should we go with DLS and John, or should we ask Yari to do it?
Yeah, maybe Yari, do you want to just get up and say a few things about AKA, or are you ready for that? Or that might be the quickest.
Yeah, so I don't actually have any slides. I can talk about the 5448 BIS and then the PFS document, both of which are working group documents. The BIS is about to be sent to the ISG, I believe, and there's been a small update of that, and that is through Joe's review, identified that there's a few references that have received a new RFC, or those references have been obsoleted, or the RFCs have been obsoleted, and so I just replaced them with new ones. So this was for the NAI RFC, for IKV2 RFC, I think the IANA considerations RFC. So that's a simple thing. I don't have any other open issues at this time.
Yeah, I'm pretty sure that this document is well ready to go forward. So I'll hit the button after this meeting.
Yeah. And then on the AKA side, there were two updates recently, one for the deadline and then more proper update today, a few hours ago. And there's no huge change, but it does include a few things, which I'm listing here from my notes. The first thing is that we changed the document to do an update. It has an update header at the top. It says update 5448, or rather the draft that will at some point get an RFC number, because we are extending it, noting that. And then I changed the wording around what we say about this document and its optionality. It's optional, but now it also says that its use is recommended, basically based on better security properties. And then there were some somewhat unclear references to the curve 25519 and how the different numbers are generated. So there was a reference to I can't remember the RFC numbers offhand, but there's the RFC that actually defines the curve, and then there's the RFC that uses it for IKV2, and I actually deleted the IKV2 reference entirely from that and just refer to the actual curve definition RFC, and simplified some AKA and SIM card terminology and made some other editorial changes. So I believe those are hopefully largely uncontroversial things. We did identify, when John and I were discussing, we did identify one remaining issue that we didn't quite know how to deal with. So this draft defines one algorithm, the curve 25519, to do things. And what it does is that it carries this in one attribute that defines, like, we're going to do this particular extension, and then there's an attribute for this algorithm, this entire style of key generation. And now the question is it sufficient to have one algorithm, or should we already from day one have two? Maybe not. I'd like to hear opinions. And secondly, how do we handle the registration of these numbers? So now it's kind of like everything's bundled together. If you do this thing, then there's one number that refers to like this particular style of key generation and this particular algorithm. You could also separate them, but then there'd be more attributes. And John had also suggested that maybe it would be possible to refer to some other registry of algorithms of this nature. That's a possibility as well. Although I was looking at some of the existing registries, and their number spaces were kind of funny, that they were not sort of neatly positive small integer numbers, but I think it was a cozy registry that was a little bit funny in that sense, that it included also negative numbers and so on. But I guess the main question is, do we need something extra in terms of additional algorithms from day one? And if so, is the current structure of attributes sufficient or not?
Hi, Ari, it's Elliot. Let me take a stab at both of those. The first is by referring the question about multiple algorithms over to more knowledgeable people who are understanding of what the state of standardization of the various curves are, because particularly at the NIST level, because if you have another standardized curve that I know they're coming along, but I don't know where they land. It seems to me having a second, another go-to one is a useful way to handle failover in case of a crisis. That's just one view of it, at least. The second point about having multiple registries is, does having an entry in the registry, what does it imply in terms of implementation? If it implies nothing in terms of implementation, then overloading sounds fine. If it implies something about an implementation in terms of, you have to be able to support it. Is it an MTI? Is it an option? Then overloading's bad.
Yeah, that's a good point. But I think there's a separation between like the requirement level, that even if we just write things in our document, we'll have to say, and even if we have 2 or 3 algorithms, we'll have to say that this one's mandatory and these other ones are optional, or all of them are mandatory. So that decision has to happen. There's a separate thing about, do we actually reuse somebody else's number or not?
John Mattsson. So I think it would be good not to specify, make the document more general and to support a set of algorithms. I think curve 25519 is correct to have as the mandatory to implement. 3GPP, when discussing SUKI encryption, 3GPP decided to standardize both curve 25519 and P256. There also has been in the past a general wish for 3GPP to have, now they did not choose that for SUKI, but there has been a wish to have stronger algorithms to be able to, for government requirements, government wanting to use cellular systems. So I think the curve P384 would also be good too, and maybe in the future it will be curve 448. But I think that would be very good. No, just to support them for, as Mo says, I think curve 25519 as mandatory to implement, everything else optional. But it would be good if the document could just, the best thing would be if we could take the COSI register or the TLS register and just refer to that and say, look, here is how to use any of these that already standardized also for this. There's complications. How do we transfer them? Is there any TLS, IPsec, COSIS specific and how do we transfer the identifiers? But these are still for analysis. But I think that would be be the best option if it can be solved practically.
So I like the idea that we could have one mandatory to implement the current one and then add one or two more. And it sounds like you have good candidates in mind, so that's great. We can put that in. I can talk to you offline. The reuse of the registry is still troubling me a little bit because it seems to me that when we add algorithms, there's always some specification needed that like use it this way, and it's not just the numbers that is in the registry. So you actually have to maybe specify also something, and yeah, it's a question of whether we can just, it doesn't magically get added to my implementation just because there's an entry in somebody's registry value.
Yeah, I think it's much easier to create your own registries and use them, because then you also, are control of your registry. So you are not end up if you're using somebody else's registry and they say, no, we don't want to have that. We don't care about that algorithm, and they don't allow you to put something in there. And then you say, but we want to, and because you are stuck.
Or they add the null algorithm.
Or they add stuff there that is not usable for you, because they say, oh yeah, we use this hash-based, it's only 100, megabytes of, this public key. It's no problem in our protocol. It might be a problem with your.
Yeah, I guess John's point was, I agree with you that it's probably lower cost for us to do our own thing. But John's argument, I think, was more like lifetime cost of this. It's initially easier, but is it cheaper in the long run if somebody else does some amount of work? So that's the trade-off.
Okay, so this is Elliot again. Short-term, long-term. Okay, short-term, clearly, I think I'm coming down on your side. Long-term, this is something that should be referred back to the IAB, because there are so many different forms of encryption used in so many different places and so many different registries. If you go through all the IANA registries, the stuff repeats itself again and again and again and again and again and again. And so it would be nice if we had a clearer way in the IETF to do that. But in order to do that, it means that we can't have a lot of customization going on within the individual uses. And that refers us back to John's work, right, in the TLS 1.3 document. How much customization has to go on in TLS 1.3 to adapt for EAP TLS, TEAP, et cetera, et cetera, et cetera. So that's the long-term issue.
Yeah, and your reference to IAB there, this IAB member doesn't know what the answer is, at least, but maybe there's some other IAB members that do.
Well, you guys are paid to do it. You pay all that money. Big costs. What do you get paid?
Yeah, a round number.
Very round.
All right. So it sounds like there's some more work to do here in terms of just getting, a couple more algorithms in there and just figuring out what the mechanism will be. So.
Yep. Thank you.
All right. Next, TLS 1.3. There we go.
So this is a presentation of using TLS using EAP TLS with TLS 103. It's in version 7. Next slide. No, that was too fast. So there's been 2 updates since the last IETF based on thanks. Based on the post working group last call comments. Changes from 5 to 6 is based on support in current TLS implementation, especially OpenSSL. So OpenSSL does not support sending the empty string as application data, even if it's allowed by the RFC. So to fix this, the ETLS draft was changed to sending 1 byte of zeros. Then it was added clarifications that the client must send a single byte, but the server must accept everything. Quite standard. Then there is, another change also based on OpenTLS is that OpenTLS does not allow the server to send early data in the server hello, which is allowed according to the RFC, but not implemented in OpenSSL. So we updated the draft to also allow sending the commit message in a separate message. And then between 06 and 07 there was a review by Jim, mostly editorial and clarifications. The commitment message is now called commitment message everywhere. There's some privacy considerations on padding, and listing that TLS 103 has padding and recommend its use. Then there is additional references to the TLS 103 RVC on security considerations and clarifications. And there's a reference to the now working group adopted draft IETF-EMU. So about certificate used, an informal reference, so it does not depend on that. Next slide. The only remaining issue that has been debated on the mailing list post working group last call is whether to allow ETLS 103 with PSK, and if yes to that answer, how to allow that. So this was starting by a comment by Thomas Haura that PSK does not provide any identity protection and does not provide perfect forward secrecy, and he suggested to allow PSK in EAP TLS. Then there was some discussion that EAP password provides perfect forward secrecy, but password is not really suitable for IoT devices. So I think that's, and IoT use cases are where people has been on the list has been wanting to use PSK authentication. Lately on the IETF list, I think most of the comments have been positive to doing this. There's been wish to use this in IoT, use it in TEEP, and so on. But if we should do that, then the question is, should these PSK use the same method, number, and should it be defined in the same document? On the first question, I would say yes. I don't think it helped having the same different number. The second, I think a new document would be the preferred. I don't think we should wait for this, and I think we need time to discuss any issues here. Yeah.
Yeah, I mean, the important thing to understand with this is that EAP TLS is used in very high security installations where additional modes are not just a bad idea, they are forbidden. Okay, so if you add this stuff into the RFC, we'll get it banned. It will not only not get implemented, it'll be forbidden to be implemented. So don't start messing with this and adding it like a zillion additional authentication modes. Do it separately, because you're talking about extremely high security installations which will not allow PSKs and other stuff, and adding a zillion modes which have never been implemented and never tested is an attack on national security. This isn't like a useful thing to do. It's very negative. And we're going to end up forbidding this RFC from ever being implemented if you do that. I'm the author. So this stuff should be taken very carefully.
Okay, so Bernard, this is Elliot. The reason that this whole conversation came up was that we're working out actual operational flows that we need for IoT, right? And for onboarding. And so that we see the value in using ETLS PSK. It's defined, right? So the question is, why can't we use a mode that already exists?
Well, you can create another code point for it, that's fine. But if somebody's, the point is it was forbidden in the original drafts, it was forbidden for a reason. It was because there were security proofs that were required to get it deployed. Those proofs are invalidated by what you're adding here. Okay, so people wanted to do very specific things, and only those things, and only those things were allowed for those particular installations. They were very high security, certificate-based things. If you want to do something else, just get another code point, do it there. Don't add all of this additional stuff, which will it'll invalidate all the security proofs that are there. Cause a ton of problems, and because of that, it will have to be banned. So this stuff, I mean, you're just going places that you just don't go there. Just get another code point and, do it separately. Just so people who negotiate this particular code point know exactly what they're getting.
So what that also implies is that any sort of new definition within a client hello that the TLS people define means it can't be re-imported here without further being standardized. Well, a code point in which
Another read code point.
okay.
Do whatever you want. Just don't stick it in something else for a different purpose.
Yeah. So the document currently says that external PSK is forbidden. So my suggestion would be we keep that and discuss PSK in an additional draft. Then people are free to implement that if they want to.
Well, the other alternative is to simply add the code point, right, and discuss it in this draft, so we don't have to constantly revisit. I'm sorry.
Mm-hmm.
So we don't have to constantly revisit ETLS again and
Okay,
again
yeah.
and again.
Mohit, no hat. So as an author, I think it's non-trivial to just say, yeah, PSKs are allowed and we are done with it. As we have seen from the discussion on the list, there is all these questions about what identities to use, whether PSKs, using ETLS with PSK, should we allow resumption tickets and resumption PSKs? So it's not a done deal. Personally, I'm fan of small modular documents. I would favor, so I agree with Bernard that probably having a different method number makes sense anyways, or type code, and then having a separate document and figure out the issues as we kind of implement this, because currently TLS PSK at least is not implemented in the open source WPS supplicant. So as we learn along the implementations, we'll probably need to make changes. And there's no point holding on to the ETLS spec until that.
Owen for Cisco. Just want to confirm, authentication PSKs are fine with an ETLS. It's just the external auth PSKs need to be split out. Sorry, resumption PSKs are fine in TLS 1.3. Those are fine. That's absolutely fine. Okay, it's just the external PSKs need to be split out. Fine.
Okay, yeah. Seems to be. So suggestion is to use a different code point. No objection to that. Seems still a little bit discussion whether it should be in this document or not.
Yeah, so let's just want to check the room. Is anybody opposed to using a separate code point for ETLS PSK? Okay, so I think that's a good direction to go forward with. The next question would be whether to use the same document or a different document. We can should we take a hum? Yeah, let's take a hum here. This is something I'm pretty sure we'll have to take to the list. First question I'll ask is if we will use if we should cover PSK in the same document. And the next question will be if we should do TLS PSK in a different document. So hum if you think we should do it in the same document. Hum if you think we should do it in a different document. Pretty close. So I think we'll have to have some discussion on the list. But Elliot,
Yeah, so there's a reason why I think we should deal with it now, because Alan and I and a couple of others have gone through all the effort to sort through these issues already on list. Right? We've done a lot of the work. We're coming close to closure on it, and so to spin up another document to have to do it causes two problems. The first of all, it's a lot of work to spin up a document for this. The second issue is that I think about it from my reader standpoint, which is, okay, great. Now I have to essentially, I have to reconcile two documents to figure out how I'm going to do my implementation. And I think that's actually more complex for me than having a single document.
And I'll give one reason why I think it could possibly be a separate document, and that is we will need some guidance from the TLS working group and possibly in a errata TLS 1.3 to give some implementation guidance on differentiating between resumption and authenticating PSKs. And getting that guidance from TLS might hold up this document. Yeah, Owen Friel.
okay. I think that should be brought up in the TLS working group. I don't know if you guys done that. I'm not sure if you'll get the guidance you want, but if we should be bringing that up, if you can post an errata or just bring it up on the list.
Mohit, so I agree with Owen. Also, I don't want to publish any spec which doesn't have implementation. So if you're going to wait until the TLS PSK implementation has moved forward in WPS applicant, we would basically hold on to the TLS document as well, which is more or less ready to be shipped. So that's another reason why I want to do it separately, so that we can have some time to implement and learn from that. It's one thing to say, yeah, we have figured out all the issues in the draft, but I'm pretty sure when we actually sit down to implement, there will be some questions that remain to be answered.
Okay. Were there any comments on Jabber? Or... It's okay. All right. So I think we'll continue discussion on the list of both resolving the issues with PSK mode, like the identity issues, I think are primarily the issues, and then also work through this separation of the documents or doing it in one document.
Yeah, second bullet, should server allow authentication with both certificates and external PSKs? This is just a draft in TLS right now. Don't know how far it has progressed, but probably a later question. Not clear that is even forbidden in the current EPTLS. Then relationship between EAP identity and NI when using external PSKs. There has been quite a lot of discussion, even suggestion on the list. A suggestion that seems to be agreed upon that when using an external PSK, you should also provide a realm that can be used as an anonymous NI. And then discussion, I think, no clear answer. Should we distinguish external PSK from resumption PSKs?
John,
Yeah.
on the point relating to providing an anonymous NAI with PSK, so Alan and I went around on this a couple of times. The issue we have to be careful about is you can't always use that anonymous NAI. You have to or it'll simply break federation. You have to be somewhat circumspect as to how you use the anonymous NAI. So for enrollment purposes, maybe you need to do something along those lines. If you're talking about TEEP, for instance, but you can't. If you're already enrolled and you want to essentially use the NAI to route on, then, which is not an unreasonable thing to do. We do it. That's a pretty massive use of EAP at this point. You can't just use an anonymous NAI, and this actually impacts EAP noob, it impacts TEEP, and a few others too.
Yeah, actually, I think the current text in the EAP TLS 103 document says that anonymous NAI is you must support recommended to use, must use privacy-friendly identifier. I think that would apply also for this.
Mohit, you can still do federation and routing with anonymous NAI as long as the realm is correct. So if you have ever used eduroam, there is a field where you put the anonymous NAI. As long as you put the correct domain part in the realm or in the NAI, your authentication request will get routed to the correct server. So I think that was an incorrect statement to say that you can't have anonymous NAIs because you need federation and routing.
Sorry. What I meant to say, Mohit's right. There's a separate discussion, and I mixed them up. There's a separate discussion going on about when to use a standard realm identifier. And that's where things can break federation. And so you're right. You're absolutely right. You can use anonymous NAI.
Fourth bullet is to distinguish between external PSK and resumption PSK, and if there should be any guidance. I think it might be hard to control both of these. External PSKs you might have control of, but it might also come from some other source. You might want to reuse existing identities in the organization and derive identities from that. The internal resumption PSKs are typically decided by the TLS application. So the EAP implementation might or might not have an influence on that, depending on how much they want to reuse or mess with the TLS code. But I think both of these things are things that should be discussed, but I don't think we can end up in any must look like this. It's more like guidance. Yeah. No.
Dan Harkins, are you done with the slide?
Yeah.
So you mentioned the CFRG is working on a PAKE selection process. So if we do separate things and have TLS 1.3 as one document and PSK as a different document, why would you want to wait for the PSK one and just do a PAKE?
Because it's probably heavy and not very IoT friendly for small devices.
Are you going to do a Diffie-Hellman in the PSK?
Yes.
Then it's not any, I mean, it's like a Diffie-Hellman and a half to do a balanced PAKE. Yeah. Right. You could do something that's considerably more than a Diffie-Hellman and a half, but I mean, I think it would behoove this group to wait a little bit to do the right thing, because even with doing a Diffie-Hellman, it's still susceptible to a offline dictionary attack after an active attack. So I think using a PAKE would probably be a really good idea.
Yeah, I think if you use password with the PSK version, it's weak. I think passwords and PSKs are sometimes people misuse it, but otherwise it's different use cases. You have PSK in IoT where you have some distribution system of these PSKs, and that's secure. Then when you have human involved setting things up, then you have passwords. Yeah.
Terokivin, I was about to comment the same thing. The PSK is PSK, which means it's a preset key, it's not password.
Yeah.
Which means it's a strong, long entropy key. And in IoT environment, it actually might be that. In lots of the other environments, it isn't. So that's why I think that there is still a use for, especially in IoT environment, for EAP PSK in that case, because it might be, even if it's only a little bit faster, it still might be enough there.
I think we should all disabuse ourselves of the notion that, the guidance we recommend in the security considerations of an RSC is how it ends up getting used, and saying, well, PSK is a PSK and not a password, and therefore people will use PSK with PSK, big long giant strings, and not with passwords, because we know that they're not going to do that. People use the tools that they have, and they sometimes use them wrong. So if we come up with tools that are misuse resistant, then it doesn't matter if they use it right or wrong, because it's still going to be strong, and that's the point.
No, it's not. Yes. We can't prove the idiots. I mean, if they use make me a tasty code as their password, it doesn't matter if you're using PEG or PSK. If the password is same for everybody and known by the everybody. So I mean, if nobody follows anything what's right, we are losing anyway. If they use weak passwords, one letter passwords, it really doesn't matter whether you are using PEG or PSK.
All right.
Okay,
Just the last comment on this topic.
Let's not make arguments from an absurd position. The absurdity of somebody using a one letter password, is not a serious argument. So.
Okay. So we have a little more discussion to be had on the PSK topic.
I think if we decide to have PSK in a separate draft, then I think the IETF106 draft is ready to proceed.
I think there's still a question on identity. Still, we need to make sure that that's clear and there's no ambiguity in the, even with certificates. So we want to make sure we verify that.
What question is that?
So how, what goes in the identity field? I mean, so there seems like there's still confusion, and Elliot was bringing up there may need to be a specific identity format. So in general, the document does not really specify, I think, the NAI. So I think it needs work. I don't have the specific right here, so. But it may be fine, but we need to make sure that it's fine.
Okay, can we, you only see the for PSK and for certificate extensions. I don't know if there's something specific for ETLS. In that case, we should make sure to very concretely take that discussion on the list. Yeah. Okay. Next. Yeah, so this is about certificate handling, and I have 0 slides on this. You can take next. There has been no comments since the last time and no updates. If I interpret it positively, it's the draft is done and ready to proceed. So I would suggest the working group last call. If and at least that forces people to review.
Just, has anybody reviewed the latest draft? I mean, I don't know if it's changed at all, but no. Okay. Yeah, so we can start a working group last call on that. Fine. So yeah, we'll begin a working group last call sometime after this meeting. Alan, can you put yourself in the queue? You're up.
There. Am I coming through okay?
Yes.
Excellent. Okay, so this is just a summary of my thoughts on identity. So as you were saying earlier, the current ETLS document is a little thin on the use of NAIs and when and where. So if you go to the next slide. there was some discussion. I had sent a long email to the list, which I couldn't find in there in the list archives. The short summary is that I think we should really recommend using the anonymous NAIs everywhere. Clearly, people should be allowed to do other things if they want, but then it won't be compatible with roaming, which is a very, very common use case. So if you go to the next slide, there's some additional discussions. So this is sort of the summary of which identities are where. You have the username, which is used in AAA routing, the EAP response / identity, and then the PSK identity or certificate common name, which is commonly used in TLS. They're often the same, but they don't have to be. I think we can agree that the EAP identity and the username have to be identical. There are requirements in the various RFCs to copy the EAP identity into the username field. So if we go to the next slide, common practice is that the EAP identity is derived from the common name for certificates. A lot of UIs also allow people to enter an explicit outer username for TLS or TTLS. With TLS 1.2, the EAP identity is exactly the common name because the certificates there are usually public. For TLS 1.3, the EAP identity should be anonymized. So we can say that generally, instead of having the user configure two different things, we could just say the EAP identity is derived from the common name by using the realm portion. So it's routable and maintains user privacy. So next slide. So for PSK identities, whether or not we allow EAP-TLS to use PSK, for pre-provisioned PSK identities, we can recommend using the NAI form, and we know that works. Or if there's a need for identities which do not match the NAI requirements, we can just say people use whatever they want for the PSK identity and then separately use the NAI for the EAP identity, right? So the idea here is it doesn't really matter what the PSK identity is. We know that the anonymous NAI always works for routing. So if we go to the next slide. And resumption, the EAP application doesn't necessarily control the derivation of the PSK identity for resumption. So it's safest to assume that it's just this opaque blob, which is not UTF-8 and not an NAI, and therefore cannot be used for the EAP identity. So again, we're left with an anonymous NAI, which then allows the resumption to be routable. And decouples routing from the PSK identity. So we can use different identities for every resumption, which gives us some level of privacy, even though the MAC address is usually there and always the same. And then it doesn't affect routability of the packet. Some of my earlier comments were that the resumption session should use the same EAP identity as the original authentication. So if you're using an actual username for the original TLS authentication, it's probably a good idea to use an actual username for the resumption simply for consistency. If you use the anonymous NAI everywhere, then you should just use it everywhere. So next slide. So yeah, we assume that generally authentication will be routed. If it's not being routed, then identities don't really matter and people can do whatever they want. But in general, it's good practice, and people pretty much always do this nowadays, even if the requests aren't routable. They just use the anonymous NAIs everywhere. And I guess my recommendation, having looked into this, is I think the ETLS draft should be clearer as to which NAIs which identity it's recommending, and why. And I think it should recommend the anonymous NAI everywhere. And I think going forward a little bit, the TLS 1.3 for other EAP types documents should probably also do the same thing. So I think that's it for these slides. If we go to the next one. Nope, I think that's it. Questions, comments?
Hey, Alan, it's Elliot. I really mostly agree with pretty much everything you said. I had a question about handling normal TLS certs. If you go back to like that slide, not PSK, but just the other form of is your presumption that there is something that approximates a realm within the cert?
Generally, it's the common name, and people use that. But based on other discussions on the list, we probably should have a separate NAI realm OID in the certificate too, and then that can be used for the anonymous outer identity. That's a whole separate discussion as to where that NAI, which field of the cert that NAI comes from, is a separate discussion. For now, I'm just waving my hands and going, it's in there somewhere. If the cert says it's for example.com, we probably want to use example.com in the EAP identity as an anonymous realm.
So the reason I mention it is that there are some implications here relating to IEEE 802.1AR, which has no such form as I understand it. And so I like your answer earlier, which is just use anonymous NAIs, but what if that has other implications, we should explore them.
I don't think it has other anonymous implications. This is really, the text on this slide is really more just background as to what people mostly use now in the common derivation, the common practice. And after going through this and sort of running down the checklist of all of the different possibilities, everything comes out with use the anonymous NAI. So I think that should be the recommendation, independent of why. It's worth having an explanation, but it's worth also just having the recommendation of, just use the anonymous NAI everywhere, always, no matter what.
Yeah. John Mattsson, you say that there should be a recommendation, but the ETLS 103 draft already have a recommendation. It says that anonymous NAIs are mandatory to support and recommended to use. So I don't really see concretely what you are missing for the certificate use case. For the PSK use case, you have a lot of other.
Speaking as an implementer, I guess the text on identities is buried inside of the resumption section. So it's not clear that for normal authentication, you should use the anonymous NAI. I had some text I sent to the list. I think I also opened a GitHub request. I think it would help to have a separate section in the document saying identities, which you can then discuss. Hey, some certificates have these identities, some don't, for resumption. In any case, for this list of reasons, here's why. For ETLS, the EAP identity should be the anonymous NAI realm. Because I guess for me, it's not clear if that text is buried in the resumption section. It's not clear to me as an implementer reading this that this field, which is separate from resumption, should have a particular value for particular reasons. Sure.
So Bernard above Microsoft, just a comment, which is that, in some systems, I have seen the Radius server make different suggestions of different methods for different people, right? So what that means is that there can be more than one anonymous NAI used by an organization. Say they decide high security users are going to all be forced to use EAP-TLS and lower security users use something else, TEAP, whatever. And it's worth thinking that the EAP identity, right, is not method specific. It's for any method. So we're really talking about here kind of upgrading privacy for really everything, not really specific to EAP-TLS. And I guess my point is that when you're asked for an identity, you don't necessarily know what method you're going to use. So saying this is the identity you should use for EAP-TLS, those are not necessarily correlated with each other.
Okay, yeah, I mean, to a certain extent, yes, but I think we still need to have some recommendation for the implementers of EAP-TLS as to when they're trying to negotiate EAP-TLS. They need to have an initial starting point for the identity, and that's where the recommendation of this anonymous NAI comes from. Okay, I think that's it then.
Okay. Thanks. I think we'll have some more discussion on that. Yeah.
Alan, I guess it's still you, so can you join the queue?
There we are. Okay. I don't have a lot to add on this document. I think there's just one slide if we go to the next one. I think the document's okay. Did get a response from Microsoft supporting this approach for PEEP. It's not clear what to do with FAST. The text in the document is sort of my initial stab in the dark, but it would be good to actually have some review of that for FAST and maybe something from implementers saying that this works and is interoperable. But I don't think anyone's really done much of anything with FAST and TLS 1.3. I think based on discussion on the list, the TEAP updates probably belong here. And then I think the document should be published close in time to the EAP-TLS document. I know the response from Microsoft was that they wouldn't touch anything, including EAP-TLS, until they could rev all the other TLS types too, or TLS-based EAP types. I know that EAP-TLS is for TLS 1.3 is implemented in WPA supplicant. I don't think there's been any progress on PEEP or TTLS there, and same thing in my implementation. Mostly because we're not really sure what to do. So if we can get some additional feedback here, then I think we can get the various open source people to update everything and implement everything, and then we know it works. I think we just need consensus from the working group that yes, this is okay, and we should be moving forward with this. Questions?
So are you in touch with folks who can help with TEAP information? Because I think that's been a kind of an open issue, is that we have some errata still open, and there's been some discussion, but not quite enough. And I know folks are talking about implementations. Want to make sure that we have the right folks involved so that we can get the document updated in a reasonable amount of time. So is the word out to implementers?
Yeah, it's basically what's been on the mailing list. I know Microsoft was saying that recently they have, I believe they have TEAP in recent previews. But yeah, there's been no sort of coordinated effort from implementers to get in a room and go, this is what we've done, let's check that it works. It's mainly just discussions on the mailing list going, I think this is what we should do. So I think I'll try and reach out to people behind the scenes and try and get some, on the record statements, but that might take a while. In the meantime, I think the document's mostly okay. My inclination is that given that PEEP and TTLS are more widely used than TEEP and easier to update, if there's any concern about TEEP that causes delays of this document, I would prefer just to drop FAST and TEEP and just have a reference of, this is what we think might work, but we're not really sure, and then rev it later so that we can rev TLS and TEEP, and TTLS and PEEP all at the same time, which are extremely widely used. I don't see any discussion on that.
Okay, so I think we'll bring this to list. We probably should have a discussion if it would help to get either having a virtual interim where we get implementers together in the same room or the same virtual room, if that would help to kind of work through some of the issues.
I think that would. Thanks.
Okay. Tuomas?
Yes. Can you hear me?
Yes.
Okay, I'll give an overview of EEP-NOOB, and next slide, please. So I'll start with a quick overview of the protocol, then the draft status, and then at the end I have a couple of technical issues that may be of interest. One is how we use the NI, and then about roaming. Okay, so what problem does EEP-NOOB aim to solve? Well, as we know, there's currently no out-of-band authentication method for EAP, and the need for this method has now been identified in the new charter for the working group, and EAP-NOOB is one solution for that problem. Next slide. And as a quick overview of the protocol, it's an EAP method for user-assisted out-of-band authentication. For example, the user could scan a dynamic QR code or NDEF tag or read a blinking light with a mobile phone to deliver the out-of-band message between the peer and the server. And this is a bootstrapping method so that when the out-of-band authentication takes place, the device is also registered at the AAA, and then that registration will later be used for fast re-authentication of the registered devices, so that no more user interaction or out-of-band communication is needed. Next slide. Here is the architecture picture. Also as a reminder, the main trick here is to do in-band communication over EAP between the new device and then the AAA server, and do most of the communication in-band over EAP, a cryptographic handshake, and then have one user-assisted out-of-band message to authenticate that in-band key exchange. And this idea has now been copied by some other specifications. Maybe I should just to advertise and remind that this originates, the idea originates from Mohit's PhD thesis. Okay, next slide. The state of the draft is that we have worked a few years on it, and on the implementations and modeling verification, and the current draft number is 7. Next slide. There have been no major updates to this version. The main thing is to update the sample messages so that they are up to date with the specification text and also have been tested with the implementation. Next slide. So here is a summary of the draft status. I think it's pretty mature now. We have 2 implementations. There is the implementation for WPA supplicant and host APD done at Aalto University, and then Contiki implementation mainly at University of Murcia in Spain. And then we have modeled the protocol with formal modeling and verification tools. On one hand, the protocol state machines and denial of service resistance properties, and then the security protocol and authentication. And I think once the new charter or updated charter is confirmed, this would be ready for working group adoption. And maybe if we can agree on that, then that can be confirmed on the mailing list after the rechartering is complete. So this was the update on the protocol, on the specification. Then I still have a few slides about a kind of more technical stuff. So next slide, please. And you can still go one more. And first about how we use the NAI. So because the device initially here is not registered with the AAA, it doesn't have a NAI. And for that reason, we use this generic NAI, and especially the generic realm, which is currently eapnoob.net, but I understand that it's better to use reserve a .arpa domain for this purpose. And why we need this generic realm, that is used for routing the EAP noob or EAP requests from the new unregistered peers to the correct AAA server. And normally we would expect the network administrators to select a server for that network that handles this out-of-band authentication and interaction with the user, and route the radius for this generic realm to that specialized server. And then immediately in the initial exchange in EAP noob, the server assigns a peer ID and a realm to the peer, and after that those will be used for routing the requests. If there is no roaming, then they can continue to use the generic realm, but usually I guess it would be good to assign a realm for roaming purposes. So this is how we have solved this NAI problem with the unregistered devices in the beginning. And then next slide, actually you can go one more if I use the pictures other than the text. So I want to explain a roaming question or problem, how we handle roaming, and then what still hasn't been done about it. Okay, so here is the first simpler roaming scenario. We register a device at home, and I use here EduRoam between a couple of universities as the example. Next slide. And when EAP noob is used for authenticating and registering the device, it initially uses this generic realm and ID, and then the local AAA or a specialized radio server for the EAP noob will handle this EAP noob authentication. And next slide. As part of that process, in the initial exchange, the AAA assigns a peer ID and realm to the device. Next slide. And later, the same device, if it moves to different parts of the network, it can use that assigned NAI for roaming, just as normal. There is nothing special about this, and this works well with the current EAP noob specification. So that's the kind of roaming that we currently support. Then in the following 2 slides, I want to show kind of what could be done. So now here is a user who is already at the other parts of the network and not in the home network. And in this foreign network, it's wondering whether it has just purchased the fresh device, is wondering whether it can register that. Next slide. The problem they have is that we would need to route the radius requests from this foreign AAA to the home AAA. And then if that was possible, then we could do the authentication with the EAP noob. But because the device now has the generic ID and realm, it cannot really connect. Your home or the foreign AAA doesn't know where to route these requests, where does the user want them. And we don't currently have a technical solution. Then next slide. And this is the final slide. So we think that there could be some mechanism for the user to interact with the foreign AAA, let's say a web page where it can request routing of the radius requests for the new device to the home AAA. And that would enable registration of new devices while roaming. And this only needs to be done once, and then when the EAP noob association has been created, the re-authentication will again work as normal roaming without any such special interaction. But this is just something that we have been thinking about, but it's not specified how to do this in the EAP noob specification. We just have been careful not to prevent this kind of scenarios in the future. That's all I had. If there are any questions or comments.
This is Eduardo Ingles from the University of Murcia. Just to say that I implemented the IPNOOB version for Contiki, and I will send the email with the GitHub project on the mailing list. Well, I implemented that with Aalto University.
Great, thank you.
Abhijan Bhattacharya from TCS Research India. So I have a few comments from a different logistics perspective. The thing is that in Bangkok, I mentioned that considering the startup community growing in the subcontinent level, what we have seen is that there's a gap in terms of securing this, the knowledge in terms of securing their devices properly. So they have good sensor knowledge, they have good knowledge on the basic hardware. But this kind of solution as a plugin can actually help them for a better service. But the problem in terms of adopting this solution that I see is that when these companies, they go to market, their end customer would not like to use anything which is non-standard. So, and also implementation wise, getting the numbers from IANA is very important because people don't really like to change the nitty-gritties inside. So probably if it is technically, it is at some stage and there are implementations already available open source, probably pushing it for adoption and standardization might find a new opportunity. That's all I wanted to say.
This is Elliot. I agree that it looks pretty stable. We're not ready to implement yet at Cisco, but if others are. What I wanted to add, though, is I like your discussion about the use of the NAI. We're basically tracking that from a TEEP perspective for onboarding.
Yeah, I think right now we're waiting for the charter is currently in IESG review, so we'll see what comes out of that. And hopefully once that goes through, then we'll be set to adopt new work items.
Roman Danilo as the AD, just to kind of be precise, the charter, we're through the internal review of the ISG. It's going for external comment, and then it'll come back to the ISG. I'm sorry? So it's back. All right, perfect. So the practical process, in case what we did is the charter result first comes to the ISG for kind of a quick look. Are you okay with that? Yes, we're okay with that. Then let's go to the community. Is the community okay with that? And based on the community comments, it then comes back to the ISG. Okay, you heard from the community. Are you now really okay with it? And then it gets approved.
Yeah, it did go for external review that finished on the 11th of November. Now it's with the IESG on their meeting on 5th of December.
Yeah, like the external review period happens just like a IETF last call, basically, and then the IESG gets another ballot. Try at it. Yeah. To repeat, Elliot, into the mic, it's on the telechat for the final ballot.
Carsten Bormann, I have been working with ADs who were at some point in that lengthy process able to say you can start operating as if the new charter was in place. So maybe you can reach that at some point. I don't know if you're there, but if you're there, maybe you can just say that and the working group can proceed.
I mean, I think we're pretty close, you know, assuming that once it goes through, then I mean, I think we can wait for the telechat. I don't think we kind of have holidays in between then, but.
Yeah, sorry. So just checking dates. It's on the telechat for December 5th. So whenever, I mean, it's in 2 weeks. So the end is near for, you know, figuring out the closure.
All right, let's move to the next presentation, which I think is Psk. Can somebody do a little ether padding? Taking some notes? If not, we'll fill them in.
Okay, this will be a pretty short presentation, I hope. Next slide, please. All right. Wow, these. So there've only been subtle, small changes to EEP Psk, but larger changes are coming. The first is that all the diagrams have been simplified. There was a lot of hopping over things, and where it didn't in the swimming lane diagrams from UML that didn't need to happen, and so I cleaned a bunch of that up. So that's done. We've done a bunch of rework of the discussion around NAI, which is almost identical in nature to what you just heard from Noob. In fact, what I'll do is I want to compare text there because I don't see any reason to be inconsistent with what Noob is doing. It seems about right. The last round of discussions, what we've realized is that at least thanks to Yoni, there are a lot of errata open on TEEP, and so there's a lot of work that needs to get done so that TEEP can be more broadly implemented. And so a couple of things are happening, I think, here. I think we want to broaden out this to a TEEP update, maybe even de-emphasize the Psk part in this to just make it more of a generic TEEP update, but also keep the additional opcodes, TLVs for Psk. And so this ties to a couple of different things. Next slide, please. So here are all of the errata for TEEP.
Mohit, so I just had a very short comment on this doing a update of TEEP and Psk. So what I apply to my own drafts, I don't ask you to do anything what I don't do myself. So I kind of recommended to myself to split the Psk part out. I would kind of recommend the same thing to you, to put the Psk part in a separate draft and fix the TEEP errata as a separate document. The reason I'm saying this is because now TEEP is finally getting implemented in Windows and in other places, and which is very nice, and we should kind of fix the errata in one document. And I'm not sure if like all use cases would use Psk, and like my Windows laptop probably won't come with LDEV ID, IDEV IDs, and so on. So maybe, as I said, I'm a fan of small modular documents, so maybe splitting them up makes sense.
Yeah, and I tend to think of it as the opposite, actually, Mohit, because from an implementer standpoint, if I have to end up reading 100 documents to implement TEEP, or actually, TEEP's not the worst offender here, but there are a couple of protocols in the IETF that are really bad because you end up really have to sift through a lot of documents. I don't want to start down that road. If we can get, many of these are, I think, relatively simple changes, and nothing should require that people have to implement a Psk opcode in the process, and that's part of the rewrite, would be that you just don't make them mandatory, but if you do, here's what you do.
Yeah, I should have added no strong opinion, so I leave it to the best of your judgment.
Yeah, and there are a couple of things here that are well outside, say, the voucher aspects of Psk that probably are worth capturing in TEEP that just got missed the first time around. So, for instance, the get CSR attributes function that's in Psk probably is something that is needed more in an EST-like function, which is what TEEP tracked, and so you probably want to keep that one way or the other. Even if at the end of the day we decided to drop all the Psk, the rest of the voucher ones. There are other aspects here too, which is if we're going to open up TEEP draft, there may be a couple of other TLVs that we want to add. In any case, I'll come to that in a moment. I went through all of the errata, and some of them are really straightforward, right? I mean, you have typos in various places that Tura caught, for instance. And some of them are also really rather simple clarifications. So you see where it says accept, accept, accept. These are just suggestions as to how we might proceed in a draft update. Not something we have to decide on today, but a rough cut of where I see things going. There are a couple of places where there's pretty involved discussion that Yoni provides, especially when it comes to some of the derivations, and those really do require more discussion when it comes to TEEP. Some of them are relatively simple, like relatively simple clarifications, like when to make sure you're using intermediate results when you're actually processing intermediate results, and don't try and return the crypto binding instead, because the intermediate result, I think, includes essentially the same crypto binding functionality. There's like Yoni's text there was, I thought, pretty close to accurate. There was like corner cases there, like, oh, what if you're actually finished? Then you actually do want to do the crypto binding, and he it's just small wordsmithing along those lines. So I think these are the lists. It's not a huge list, and it's just something I think we can knock through over the next couple of, I won't say next couple of months, but probably it's going to take a couple of cycles of meetings actually to make sure we're comfortable with this. Next slide, please. Okay, so these are sort of the new TLVs that are in there already, and then I think we just go through and sift and decide which ones are useful to keep, which ones we might want to add. And I think this also ties quite closely to the onboarding discussions that we're having as to how we bind to various onboarding mechanisms before you even get to EAP. So for this purpose, what I'm suggesting is that we slow roll some of this, and if it really slow rolls, then I would have to agree with you, Mohit, that we would want to separate out the clarifications. But if it's not going to be too slow, then let's just proceed and see how far we get. So I think there's one more slide. Right, so yeah, there's this interaction aspect. So how does TEEP interact with other 802.11 capabilities and DPP in particular? How do you do network selection from wireless, and how do you bind from a DPP transaction into TEEP if you're going to do that? And some of that has to be worked out architecturally, and this ties to the discussion that we've been having about, how these building blocks look together, and what does that mean from a how do we discuss that at the IETF? So I don't want to blow up this into a huge issue. It's really not, I don't think, but we are tying, this is a little bit bigger than just TEEP. Next slide. Okay, so one of the things we can do is just have a section that goes through and accepts, or provides an update on how we deal with the errata. Then we have another issue, which is how do we deal with TLS 1.3. I sort of like the idea of having that done in the other document that Alan's doing. One of the reasons is that I don't think, maybe Dan is, but the rest of us aren't really TLS 1.3 experts. And if we could knock that through in the other document, I think it'd probably be easier. But I'm not religious about that either. The proposal here is less focus on Brewski, more focus on update. As I said, roll it slow, get some more code going. We actually have some code that we've done in both WPA supplicant and in the host APD code. That code's not yet ready for release because it's slightly embarrassing in terms of 1 or 2 points, and I would rather not be quite that embarrassed. So I think at the end of the day, probably in March, the document will look a little bit cleaner in terms of how this looks, and that will give you a good view as to whether or not to adopt, is the way I see it. And that would be where I would leave things for now.
Yeah. One of the things I kind of hope is we could knock through the errata. We can resolve the errata without having them in the document, and then just the document would just reflect the changes, right? So
that would be fine.
I think we
don't
can
mind.
do that, kind of in process as we work through them, because some of them, might take a little bit longer, but many of them, like you say, are pretty straightforward. And if we can start knocking those off, I think that would be helpful.
Okay. So here's what I propose then, Joe. I will take as an action to post these each as an issue, right? Each of the errata as an issue with a proposal how to address. I suggest the chairs track them as separate issues, right? And then you guys have the option of closing or not, and based on the working group's view. And then as we're doing that in parallel, we can also deal with the other deep work that's being done. Okay.
That sounds like a plan.
Okay. I'm done.
Cool. Who's next? You just pick some. Yeah. Max.
Hello, everybody. I'm Max Pala. I'm here to talk about EEP creds. We already presented last time on this. Want to provide some updates, some consideration about the work that we're doing with its applicability, and what are the next steps that we envision. Next slide, please. Okay, so problem statement. I work for Cable Labs, so we have our members, our operators that tend to deploy different type of networks, from Wi-Fi with public access point to cellular networks, CBRS, which is practically 4G and 5G doing in unlicensed spectrum, like Multifire, or our networks like DOCSIS networks, right? However, there's one problem that our members always report. It's very difficult to dynamically manage these credentials for their access networks. And they really would like to have the possibility to change these credentials depending on the risk level that they want to accept in their networks, right? So today it's very difficult for them to have a centralized system that does this across different networks, different technologies. Next slide. And of course, we don't use one type of credentials. We use different type of credentials like username, password, secret keys, and certificates. So certificate is one of them. And usually having multiple methods can improve device diversity in your network sometimes, and the possibility to switch between type of credentials. And security manages this credential is not easy, right? So we've seen some proposals to manage the credentials through EEP, but there's no consistency about being able to manage all type of credentials. We focus mostly on certificates because this is a very common use case, but we have other use cases that involve, keys or username and passwords, especially in IoTs. There's a mixed type of credentials that have been deployed. Next slide. So what are we trying to focus with our work? So our work is trying to provide an encapsulation mechanism, right? So that you can use your own provisioning mechanism and or encapsulate standard mechanism that already exists. Why do we think this is a good approach, right? We work in many different environments, like WFA, for example, where they use a different approach. They propose that devices get their own IP address, get in a jail state, basically can reach a OSU server, which is a online sign-up server. And then from there, then they can get their credentials and then authenticate to the network. However, some operators reported that they don't feel comfortable deploying this type of solutions because now you have devices that are not authenticated and they can probe your network because they have IP, so they can have routability. We think that this solution solves this problem because now you cannot route your message, and from a security standpoint of view, it makes a lot of sense. And as Mohit before suggested, also for Brusky, we think that with our protocol being generic, you can have profiles for that for your use case. So, for example, if you want to implement a full set of standard, like EST, you can implement the full EST, or you can just implement the renewal because that's the use case that makes sense for you. Next slide. So just very briefly and very quickly, how we organize the EAP creds. We try to provide 3 different phases for now: the initialization, the management, and the validation. The initialization is the part that you can use to bootstrap the process. You can use tokens or voucher that can be bearer tokens or can be tied to a key. So there's all methods that you can use for authentication. But basically, the initialization says, the device says, oh, these are the credentials that I have for your network. Do you want to do something with it? And then basically the server can start, if it wants to, start the management phase where you can renew or deploy new type of credentials if it's supported by the device, and then optionally verify that actually what the device has corresponds to what the server thinks it should have. Next slide. So what has changed so far? Well, we simplified the proposal because we received feedback from the work group. These are documents that are very long. We want them to simplify so they can be understood better. So we decided, well, from the main list, they said it's okay if you say that you have to rely on a secure method before executing this. So this actually helps us because we say, well, you have to have a secure channel, but we're not going to go into the description how to get that. Once you have that, like for example for EAP-TLS, EAP-TEEP, or other mechanism, then you can use this method. And we simplified certain things by removing that, but at the same time we added new text because one of the items that was left over was to define one basic protocol that could handle all different type of credentials. We call now SPP, or Simple Provisioning Protocol, but it's just a very simple thing. And basically this tried to provide one method. So it's not the only method. So the EAP creds is meant to be an encapsulation method. And next slide. Because of this, right, we thought about simplifying the document by removing the SPP. We just put it there, maybe put it in a separate document so that EAP creds is a shorter encapsulating method and the SPP can be implemented there or not. Now, there are some other things that we might simplify the document to make it even shorter, but I hope that we can do it in the next version of the draft. Next slide. Of course, I want to thank everybody that really helped us in making the proposal better, and also the chairs, because the charter text has been a long time discussion, and finally we get there. Yeah. Thank you so much. Next slide. almost. What are requests here? So, of course, we're focusing on the use case that makes sense for our members, because this is something that we want to deploy in our networks. We also working with CBRS, where I think on the 14th was for release 3, EAP-Creds was adopted to manage the credentials for cellular networks, for CBRS networks. Then we're working also with the Wireless Broadband Alliance. They were interested in to see, can we use this to provision credentials in their environment and Wi-Fi? We're going to present there soon. There's no date yet, so this is some work that can go also in the WBA. Next slide. We don't think the document is ready for thinking about adopting the work group. We want to simplify that and make some tweaks before we think it's ready for evaluation. But we hope that we can do it soon, and maybe by the next time we can think about adopting it. This is the reference for the current ID that we have. I know it's late, and most of you have the eyes like very open, but if you have any question, please.
Hello, I'm Frank Xia, Huawei. In a lot of IoT or device onboarding procedure, usually we have some pro-provisioning or credential on the device, and we use it for the authentication and for the later network access control. So, but here you propose that we do the credential provision, when the device is joined the network. So I don't know the relation between the current method and what is the typical use cases for your method.
Thanks for the question. With this method, actually, you can still continue to use that approach, in the sense that when you during the initialization phase, if the device doesn't have has some credentials that you may leverage to register the device, that happens in the 2 initial message. So there's 2 messages in the initialization phase, and you can use that method to leverage credentials that already exist. But on top of that, you can decide, well, I like these credentials. These are the credentials, for example, that were put there for certification. You have an OCF device. You have some devices that have certification, already certificate, but that particular method of authentication for your network, you don't think is appropriate, or let's put it this way.
You want to change.
So you can use that credentials to register the device, and then deploy the credentials that you would like the device to use the next time they access the network. Something like that. So think about, you might have a voucher, you might have something that is tied to a key or not, or just presenting one-time token, right, to register the device that you obtain from a website somewhere. We don't specify that. This is outside the scope of the protocol. But our use case, for example, for our DOCSIS network or CBRS is you have some SIM credentials. You can leverage them to deploy this, other type of credential like certificates or username and password in that environment. The same things we are thinking for our next generation of cable networks that we are working on delivering the 10 gigabit platform. We think that because the added number of entities that are going to be on our networks, we need to have some form of authentication and credentials managing that we use through EAP, not only for the clients, the cable modems and DVRs, etc., but also for the infrastructure. So this would allow us to have a very centralized system for all our operators, which is very interesting for them.
Okay. Yeah, thank you for the clarification. I think in general, I like this idea. Thank you.
Thank you.
Hey, Max. So I think there's a lot here that you're doing that I think is really interesting, because it tracks precisely to this morning's conversation, right? In terms of how we onboard with IoT. I have one major concern. Well, it's one major concern, but it's a lengthy one, and I'll apologize in advance for that. Which is, first of all, it seems like you have sort of the kitchen sink approach here, right? In terms of there are all these different mechanisms that you're going to try and reference with an EAP-Cred. What we are suffering with in IoT right now is fragmentation. of all this. And I realize you're trying to defragment by finding at least one consolidation point, but I'm concerned that with so many mechanisms, it actually won't consolidate. And so one of the things that we talked about this morning was, can we distill down architecturally what is really needed to bind between these, the input process for EAP, if you will, versus the output process from what came before. And I wonder if we want to just take a step back a little bit as we go through that and say, okay, can we distill this down to something like we discussed this morning as a, something like an EDCSA public-private key pair, or something along those lines. Maybe the public EDCSA is probably a little too specific, right? You probably need a code point approach in this. And I'm not even sure about how to manage the code points in that regard. But if we can distill that down, then there's another opportunity here. And the other opportunity is that our two drafts merge, right? And that we sort of proceed forward along those lines. I haven't actually thought all of that through, but I think that's a discussion we should have. And I really like the idea of merging in one particular regard, which is less fragmentation. But as part of that, I think we need to understand each of the use cases that you were attempting to address with all those different enrollment mechanisms. And, I think the gentleman from Siemens are here, and in your draft in Anima, right? You have you had to try and chisel down, right? What sort of enrollment approaches you really wanted to tackle, right? Do you want to throw SCEP in yours, for instance? And and I think there are some use cases that they have, right, that need to be reviewed in this context. So as part of this, if we can distill this down, then we can reduce the fragmentation, and that will accelerate deployment.
Yeah, Elliot, thank you for the question. Yeah, definitely, if we can maybe merge the two proposals, if we, they both fit the use cases, great, less work and better work. So far, architecturally wise, what we are working on is try not to put architecture in this, but let you decide the architecture. So this comes from our operators. They usually have some purchasing power for devices, so that usually helps them to have more freedom when they have to decide how to manage the credentials. But coming to the point that you were saying about the defining all this fragmentation for these provisioning protocols, I totally agree with you. We have that problem, and this is not a new problem. Whenever you need to implement a provisioning protocol, you have to choose which option of that provisioning protocol, etc. That's definitely true. My plan is not to do this work for every protocols that we have. As I said before, we have a proposal for the SPP, which is very simple, meant to be the minimal version, not super flexible like other provisioning protocol, but sufficient. Let's put it away. Sufficient for a good implementation. And if you want to go over and have using something like Brusky, etc., you could still integrate that, right? The other thing that I wanted to point out, this could be used, for example, also, and we talked about this morning, when you have DPP, for example, the approach that they're using for the personal use in the WFA, to be transported over the enterprise, so over EAP, by encapsulating the DPP packets on the EAP. So you could potentially use DPP also through EAP. It's just an example of how this would enable new tools that might find new use cases. But so this is all.
Okay. Thank you. Let's go to the next presentation, which I think is you should be on.
Okay, I hope you hear me fine.
Yes.
Okay. So my name is Jan Frederik Kriekers. I'm currently a student in Bremen in Germany. And I have submitted this draft just as an idea. So you can go to the next slide. I'm working on at our networking center in Bremen, and I am dealing with EduRoam. And one experience I had when dealing with EduRoam is that the certificate checks on supplicants in EAP-TLS are known to be faulty. And with faulty, I mean not badly implemented, but they don't really happen in a way that that they should happen. So they use very insecure defaults. For example, in Android devices, there was not a really default for checking with Android versions, at least prior to version 7. I'm not quite sure about that. So the certificate checking was disabled by default. Current Androids have this option, use system certificates with domain input and not really a documentation what this domain should be. Windows, Mac OS, iOS, they question the user for the certificate, and at least for Windows, you just see a fingerprint and no information about the common name or the issuer. So that is a big issue in EduRoam in Bremen, at least. So the reason for that is, from my perspective, that the EAP-TLS specification lacks a specific method or specific data to determine if the certificate is valid for this specific use. And I think this should be solved by giving the supplicants some means to determine if the certificate is valid for the intended use by including information into the certificate that is implicitly defined by the communication context. So if you can go to the next slide. My proposed solution for that is to add a new certificate extension that explicitly defines a valid realm for this certificate, for which EAP realm this certificate should be used. This is a big advantage because the username is implicitly known from the communication context, and the realm can be extracted from that. And CAs can validate this if the realm is a DNS name, and especially in EduRoam, this is true for the realms. I have asked for comments on the mailing list, and I have some other ideas seen on the mailing list. So if you can go to the next slide. There is RFC 7585, the NAI realm specified there, which is intended to help with roaming federation connections. So this is one idea that was very like the first response that I'm redoing this work here. From my perspective, this could be a solution to also use that for EAP-TLS, but I don't think this is a good idea to just simply reuse that, because it is not the same scope. Another idea would be to specify a specific prefix for the subject alt name, DNS name, or even for common name in the certificate. For example, eaptls.uni-bremen.de for the uni-bremen.de realm. But my suggested solution would be to use this new certificate extension. So if you could go to the next slide. Yeah, so the feedback I received for that is to possibly just reuse the OID from the RFC 7585 NII realm. Maybe, and that is also an idea that came to my mind after submitting this draft, is to also add a specific extended key usage for EAP-TLS server authentication, because currently, speaking for Bremen, EduRoam as well, the certificate we use has the extended key usage for TLS web server and client authentication. And from my perspective, this leads to quite a lot of problems, because it is quite easy if people just type in their username and their password to set up a rogue access point and get credentials there. So yeah, this is my first draft for the IETF. So I would be very happy to receive feedback if this goes in the right direction, if there's something I have missed, if this is useful.
Hey, this is Elliot again. Jan Frederick, thanks for the draft. I think this ties a little bit to the work that Owen's doing, if I understand correctly, in terms of realm identification. And I think, Owen, you're going to talk to that. Is that right, later? Or maybe not in this room, but I think we have looked at similar issues in terms similar aspects that I think relate a little bit to your ACME work. And so I think there are a couple of things that are hiding out there. What I was going to say is I was a little unclear of the use case, though, in terms of when you need that realm in the available in EduRoam, for instance. Is it that the certificate is being presented inappropriately elsewhere, or that you're not being able to select the certificate for EduRoam's use in a context of the Federation?
So the main problem with the certificate checking is that it is quite common, or it was quite common for a long time, that users just typed in their username and password and did not select any certificate attributes, and especially with the user interface in EduRoam in Android, this was the easiest way. And my aim is to help to get a secure default that supplicants know exactly from the certificate that this is valid for the intended use.
So this is Owen, just to clarify what Ali was talking about. What I'm going to talk about in 5 minutes' time is the other side of the house, which is how ACME can be used to issue client-side certs. What this is more relevant for is Brisky Cloud, where it's going to come up at Anima later on in the week, which is when a cloud registrar redirects an entity to a AAA, how does the entity verify the AAA's identity?
Bernard about Microsoft. So I have a question about how you intend this to be used. Is the idea that you don't feel that the user should be prompted to okay the certificate, and that should somehow automatically check the NAI against this NAI realm and just allow it? Is that the idea?
Definitely, yes.
Yeah, I guess I don't understand. It seems like a very dangerous thing, because what prevents you have a cert to claim any NAI realm, right? They did, like my corporation, I'll claim I have owned the NAI realm for whatever. I don't actually own it. It has no relationship to the cert. And now you're not putting up a dialog box, so I can basically infect the user system with a false NAI realm claim. Right? I can put whatever I want in there. Like I'm Joe Blow's fish shop, and I'll claim, that I own the NAI realm for, NSA, US Gov, right? And you'll accept that automatically. Is that the idea?
Well, basically, the idea is because in EduRoam we deal with public CAs, public trusted CAs a lot, to help to have this certificate attribute also verified by trusted CAs. So that, of course, if I have control over uni-bremen.de, then I should be the only one who is allowed to be issued a certificate with the uni-bremen.de realm.
Yeah, I guess I don't understand how you.
We're gonna cut the line, or hold the
Yeah, Carsten Bormann, just a quick observation here. Improving the security can be done in several ways here. And given that we are talking about an environment in which most endpoints are broken, it's really hard to reason about security. And one observation is that it really helps to be able to build your production system out in such a way that it rejects a larger part of the broken end systems, of the systems that are not only broken but also misconfigured. So that's maybe a slightly different objective that we have in mind here than you are usually working with.
Alan?
Yeah. So to address Bernard's point, that's certainly true. But I think one of the issues now is the supplicants by default don't trust any of the root CAs for TLS authentication. They do trust it for HTTPS. And one of the issues is that all of the TLS server certificates have this TLS web server OID. And I think it would help if the CAs would issue certificates specifically for EAP-TLS, at which point the supplicants could default trust all the root CAs and then validate that that certificate coming over EAP-TLS is actually an EAP-TLS certificate. So I think what Jan Frederick has pointed out here is an issue not just with this particular OID, but I think there may be a need for a larger EAP practices document as to what the supplicant should do, what the CA should do. And I think it would certainly help with adoption rather a lot, because it'd be very, very nice to be able to say, you know, here's my identification, I'm in realm X, and I connect to some random SSID. Hey, I get a certificate which says it's for that realm. It's signed by a root CA I trust. Therefore, I don't have to do the whole clickety-click thing that everyone has to do now. So I think this is an issue which is worth working on.
Okay, thanks. We have to move on to the next presentation. Thank you, Jan Frederick, and I'm sure we'll have more discussion on this on the list. So.
Everyone wants to go to the bar, so I'll be really quick. So it's a problem that Avaya and Cisco are trying to solve. Go on to the next slide. So what this describes is it's a mechanism by which we can use ACME for integrated with multiple different protocols that are used for issuing device and client-side certs. Next. So the doc describes multiple different use cases, how ACME can be integrated with EST, with Brusky, with the new Brusky Cloud Registrar. But for what's of most important to this room is how it can be integrated with TEEP and with TEEP Brusky, or which has been rebranded as TEEP Update with extensions for bootstrapping. And I think that ACME actually requires the extensions, the new TLVs that have been defined in the TEEP update. So I don't think that ACME will cleanly integrate with TEEP. There's a couple of problems with TEEP as it currently stands. Next slide. So what's changed since we last presented this? So what ACME integrations used to cover was ACME for subdomains as well. That has been broken out based on feedback at the ACME working group last session, and that's been presented at ACME this time around. What ACME for subdomains does, it's a very nice integration for client-side cert issuance. It allows an ACME client to prove domain ownership of a parent domain, and then the client can then send in certificate requests for hundreds or thousands of subdomain certs off that parent domain without having to prove domain ownership explicitly for each client-side cert. The Brusky Cloud Register use case has been added, and there's been a couple of updates to Elliot's draft. The two most important ones that we've added is CSR attributes one, and one that you missed in your presentation, Elliot, is a retry after TLV. And the retry after TLV will be really, really useful when the TEEP server wants to issue a cert to the client but is not willing to do it yet. It can't do it yet. Yeah, so next slide. So at its core, like this draft, it should only be informational. It doesn't require any changes to ACME. It will not require any changes to EST or TEEP update. What EST and TEEP do is EST and TEEP define protocols by which the client can interact with the server, but it doesn't specify how the server interacts with the backend CA. And ACME can be used to integrate with the backend CA. Next slide. It's just an overview of the flow. So this is boilerplate ACME. This is how you can use ACME to do domain claim using DNS. Next slide. This is just skip over this. That's just standard TEEP tunnel establishment. This is where it gets interesting. So this is standard TEEP, but doesn't have the new TLVs that have been defined in TEEP update. The client sends in a PKCS10 request to the TEEP server. The TEEP server then turns around and sends a ACME new order request followed by an Acme finalized request, followed by the Acme certificate request. Again, everything on the left-hand side is standard TEEP, everything on the right-hand side is standard Acme, no changes to either protocol. And it ends up with the client being issued a certificate that is sent by the TEEP server using the PKCS7 TLV to the pledge. Next slide. So what the next slide covers, it's the new TLVs that have been defined in the TEEP update. It defines what happens and how a client leverages these new TLVs. So first is the client doesn't know what attributes to include in the CSR request, so the client sends a new TEEP CSR attributes request to the TEEP server, gets a response. So for example, that could include specific information on what subject to include or what SAN to include. The client then, in step 3, sends a PKCS10 TLV to the TEEP server. TEEP server turns around and interacts with Acme. Acme will turn around and say, the status is processing, I'm not ready to issue a cert yet, I'll issue a cert in a certain period of time. Acme has a mechanism for specifying a retry after interval to the Acme client. The TEEP server is the Acme client and turns around and uses the new retry after TLV to send that retry back to the client. The client will then retry after that timeout has occurred. And the way that the TEEP update draft is currently specified is there's 2 different mechanisms for doing the retry. One is within the tunnel, if it's a short interval. 2 is outside the tunnel, if it's a long interval, and that's indicated via either a 1XX or a 2XX error code in TLV, in TEEP TLV. And then finally, after the retry, the client, what's illustrated here is it's happening inside the same tunnel. The client in step 9 sends the exact same PKCS10 request again to the TEEP server. TEEP server then goes to Acme, and the finalized order is ready. It downloads the cert and returns it to the client in the PKCS7. Next slide, the final slide. So discussion of what's missing from the draft is security considerations, and the security considerations need to touch on all the integrations, so EST and Psk and Acme and TEEP. But the biggest thing that I'd like to discuss here, and the questions I'd like to get feedback from, is because this spans multiple working groups, Acme, Anima, EMU, what do we do with this? Where do we go next with this draft? Several people and several organizations have expressed interest in it, but we don't know where it lands. That's it.
People are saying sect is bad. We're whispering it, but that's
Yeah.
All right, any questions, comments, or?
Not really on this point, some other point. Just a clarification question. When you do the translation between the 2 protocols, how do you handle the account management that is in Acme? So is the account that is used to request the certificates from the AAA server or from the client?
Well, the TEEP server is the Acme client.
Oh, right. Okay, thank you.
Yeah.
Roman?
Roman, so back to the kind of the question, where do we do it? Unfortunately, I know the sec dispatch agenda is full, so we can't take it there kind of later this week. So we can start. I'm sorry? There is still that. You're right, Ben. Yeah, the question I was going to ask is, I mean, would this working group be against doing the work here? And we can ask the, Acme as well.
Hi, Frank. Yeah, just a quick question. Is there any relation of this draft with Psk?
Yes, it can integrate with Psk.
What relation?
So Psk is built on top of EST. So the actual cert enrollment mechanism in Psk just uses boilerplate EST.
Yes.
And this can integrate with EST, and that when the client sends the EST simple enroll or full enroll message to the EAP server, the EAP server can turn around and turn it into an Acme request.
Okay,
because and in fact, if you read the EST draft says that when the server is deployed as a registration authority, as an RA, the protocol and the interactions between the RA and the certificate authority is out of scope of the EST draft. So it could be Acme.
Yes, but my point is that yeah, I understand your point, but that's just the very last step of the enrollment of the device. So,
yes.
But Psk is mainly about the from the beginning until the EST. So yeah,
the only relationship is what's behind that EST simple and role API, and what's behind the EST simple and role API could be Acme.
My point is that comparing to other working group, I think the Psk has little relation, very few relation with your work. Other may be more related.
Yeah, I think, we can do a poll here. I don't know if that's gonna, I think, how many people have read the document? Okay, 3 people. So I think we have to get a little more, people looking at it, and, if there is interest, I don't think that it's impossible to do it in this working group. It doesn't strike me as necessarily being the most logical group to do it in. I suppose it's as good as any.
So, Joe, one of the agenda items for Acme this week is should it be adopted by Acme?
Okay. So if they adopt it, then that's great.
I'd say the answer would be no from Acme, though, right? So they'll say no, take it to EMU or take it to somewhere else.
The only reason I think this is Elliot. The only reason I think it should be adopted here is that it's going to normally block on the TEEP update. It's going to normatively block on the TEEP update. So. If the work's happening here, if you're going to normatively block on something in Acme, then it's a 7-10 split.
Yeah. Okay. Well, I think there's more discussion to be had. All right. I think that's it for this edition of your EMU working group meeting. Yeah. All right. Yeah, definitely. Thanks. That worked okay, I guess. Hey, John. So, I just, since there are these questions, I just was unresolved, right? And maybe it's fine, the text on the NAI.
Actually, okay. They add some clarification.
Yeah, it's not like a big deal.
No, yeah.
Yes.
This text is currently in the privacy section, and maybe we can have a section on this identity. We can have, because currently the privacy section says that